Well, hello there. Mr. Bucko here with problems number 4 and 5 from your Algebra Chapter 1 practice test. I have 4 on the screen where it says 3 instances of a pattern are given below, and we want to rewrite the pattern using one variable. And the key to do this is to identify what is changing from one instance to another. So when I look at these 3 instances, one thing that I notice is that the first number is always a 5. 5, 5, 5. We're always multiplying it by something, and then that something that comes next is changing. So that tells me that this has got to be some sort of variable here, because I don't know what's going to be next, especially with what I'm looking at. It's a 6, and then it's a 3/8, and then a -11. Who knows what's going to be next? So that's going to be in the place of a variable when we write the generalized pattern. Then we have -7, that always stays the same, and then we have a times, that always stays the same, and then here's the same number that is shown up in the first or the second digit in the equation here. So there's another thing that's changing, and then we have a +9, and then again we're multiplying by what's changing again, and then it equals, and then we have 7 times, and then we have what's changing. Now what's nice about this is the things that are changing are always the same. So here's what's changing, but the 6 and the 6 and the 6 and the 6 are all the same. The 3/8, 3/8, 3/8, 3/8 are all the same. The -11, -11, -11, and -11 are all the same. So those can all be the same variable because they're the same number. So if I'm going to rewrite this with just one variable, I'm going to get this sentence here. So notice we have the 5 and the -7 and the +9 and the 7 here because those numbers show up in every single instance. They will be there if we write another instance. And now the numbers that are changing have been replaced with x's because we don't know what can be next. It could be anything. So we're going to use variables to represent those. So this is the generalized pattern rewritten with one variable, and they're all the same variable because in each instance all those values are always exactly the same. So we have this 5 times x minus 7 times x plus 9 times x equals 7x. Next we have number 5, which multiplication property is illustrated below, where we have 1 times 2 times 3 equal to 1 times 2 times 3. We're on the left side, we're doing 2 times 3 first, and on the right side we're doing 1 times 2 first. So we have to determine whether this is the associative property, commutative, both of them, or neither of them. So what we have here is, first we'll look at the associative property. The associative property is when the numbers inside, or terms inside the parentheses change. The commutative property is when the order of the numbers changes. So just describing both those two, we can take a look at which one this could possibly be. So commutative only, let's see. Do the order of the numbers change? We have 1, 2, and then 3. Then we have 1, 2, and then 3. Notice the order of the numbers have not changed. It goes 1, 2, 3 on the left side, 1, 2, 3 on the right side. This automatically means that this is not the commutative property because the order of the numbers has not changed. So this is not the commutative only. It's not the commutative at all. So it can't be both because it's not the commutative. The associative property says that what's inside the parentheses changes. On the left side, 2 times 3 is in the parentheses. A 2 and a 3 in the parentheses. And on the right side, a 1 and a 2 is in the parentheses. Those are two different pairs of numbers. Yes, a 2 shows up both times, but they're not the same for both numbers. So this is an example of the associative property.